All right, guys, we're going to be moving on to 4.4c. I told you, you're going to think this thing's never going to end. As a matter of fact, we're going to get to 4.4g before this is all said and done. But it's just because we're kind of taking it slow and looking at some different things kind of more slowly than what maybe the book is indicating that we need to do. But that's okay because I want to make sure that you get it before we move on. So a couple of different things we're looking at here in 4.4c. Again, we're looking at dividing by monomials. We're also looking at greatest common factor, GCF. Okay, this is things again that maybe you've understood since grade school, but when you start throwing some variables in there, maybe some confusion could kind of exist in this. Okay, so we're going to look at 4 problems only today, not a whole lot. You've got about 16 problems that you're going to have as part of your practice, but I will go ahead and tell you that since you're watching this video, that you're going to get 4 of those questions right for sure, because we're going over them right now. Okay, so this is not 1, 2, 3, 4 on your exact practice, but if you're paying attention, you're going to get these 4 particular problems right because they are on there. So let's look at this first one. We've got 12x minus 27 divided by 3. And I want you to understand that a fraction is nothing more than a division problem. And so this 3, the other thing I need to make sure that you understand, and one of the reasons I wanted to look at this example is because this 3 right here, really, it applies to both of these terms. Okay, this could just as easily been written 12x over 3 minus 27 over 3. Okay, so I want you to understand that a fraction can be broken down like that as well. And so that 3 applies to both of these terms. All right, so when we're talking about something like dividing by monomials, the only way that you can really eliminate or help to simplify is if this 3 in this instance goes into both of these numbers. In other words, we know that 3 goes into 12, correct? But what if this here was 26 or 25? 3 won't go into 25, okay? So you would not be able to simplify this particular problem. Since we're dealing with numbers that 3 goes into both of them, then we can actually rewrite this and simplify this, okay? So what we would do then is we know that 3 is really like our common factor. It is a factor of 12 and it is a factor of 27. So looking at the problem like this, it kind of makes a little bit more sense. 12 divided by 3 is in fact 4. And you notice that I don't have an x in every term. I've got an x in just this one term, but I don't have an x in every term. So it kind of works the same way, because that variable, again, could be any number. That's really what we're saying. And so unless there is an x in every term, then I cannot take that x out. That x has to stay, okay? So I'm going to end up with 4x. And then I've got 27 divided by 3. Well, 27 divided by 3 is 9. But remember that there is a negative there, okay, right there in your problem. So a negative divided by positive would still be negative. So it would be 4x minus 9. And again, this 3 divided by 3 would just go away. And now all of a sudden, this is the only thing I'm left with for an answer. So that would be my simplified answer. Now let's move on down to number 2. So using that same methodology, let's kind of think about the numbers first, the coefficients, okay? The coefficients are the numbers in front of the variables, and let's just focus on those. So I have a 20 and a 4 and a 32, okay? So what is the greatest, is there a greatest common factor or a common factor between these 3 terms? Well, we know that there is. We know that, in fact, a 4 will go into both of these numbers, okay? So 4 will go into 20 5 times, okay? 4 will go into 32 8 times. And you notice I'm just leaving a little bit of space because I may have to do some more work here. And then 4 will go into 4, which just leaves me 1, really. So that I can go ahead and write that just so you can see it. But those are my coefficients, okay, that I've kind of dealt with already. Those are gone. Now look at what I have. I have an x to the 5th here. I have an x squared here, and I have an x squared here. So because I have at least an x squared in every single term, I can eliminate the x squareds. So what I mean by that is this x squared is going to go away, and this x squared is going to go away. But if I take x squared away from x to the 5th, what am I going to be left with? Well, think what I'm really saying, and what I really had here was x to the 5th divided by x squared. And we know from rules of exponents that when you divide exponents, you actually subtract. So it's going to leave me with x to the third, okay? So I'm going to be left with x to the third here plus 8 because that was a positive 8. And remember, my x squared here has gone away now because I had an x squared term in at least every one of them. So now I'm left with this, which again can simply be simplified as fx to the third plus 8, or 5x to the third plus 8. All right. So now let's talk about the greatest common factor piece, because here we're just given this binomial and we're asked to find the GCF. Okay, so here these instructions kind of go here, and these instructions kind of go with number 3 and number 4. Okay, so here I'm trying to find greatest common factor. Well, let's think about the greatest common factor between 30 and 36. 30 and 36. We're looking for the greatest common factor. Well, let's just take the factors of 30, and you'll remember doing either factor rainbows or factor trees, whatever maybe you did in grade school or middle school. So we look at the factors of 30, 1 and 30, make up 30. 1 times 30 would be 30. And then we just keep going down the list. So now we have 2 times what would give me 30? Well, that's 15. And then I ask myself, well, does 3 go into 30? Yes, it does, 10 times. And then 4 go into 30? No, it won't. And then 5 times 6 will give me 30. And as soon as I see one number right after the other, I know I'm done, right? Now let's look at 36, the factors of 36. And that's 1 and 36, 2 and 18. I'm moving a little bit fast. 3 times what gives me 36 would be 12. 4 times 9. And then 6 times 6. A lot of factors for 36, right? But remember, what are you trying to find? You're trying to find the greatest common factor. So you're looking through your biggest numbers over here, and you're trying to see what the biggest number it is that has the same over here. Well, 30, no. 15, no. 10, no. Oh, here we go, 6. So 6 is my greatest common factor. So I could go ahead and pull out a 6. It's kind of like the reverse of doing the distributive property, right? So you're pulling out a 6, okay, out to the front. Now the other question you got to ask yourself is there an x in every term? Well, there's an x in this term, but there's no x here, right? So there's not an x in every term, which means it is not a greatest common factor because it's not in both terms. So the only thing literally that I could pull out of this is a 6. Well, now I can rewrite what I have inside. So 6 times what equals 30? Well, 6 times 5 is 30. I actually need another x because I don't have one on the outside. So I write my x here. And then 6 times what would give me negative 36? Well, I need a negative for sure. And 6 times 6 will equal 36. So this is the same thing as this, okay? And again, you could do the distributive property just to make sure that you got it right. 6 times 5x is 30x, and 6 times negative 6 is negative 36. So you can kind of see here how that this is exactly the same thing. It's an equivalent statement, but again, it's a more simplified statement. In mathematics, when you break something down, then it becomes more simple than it did when it was written in its more complex form, okay? So last but certainly not least, we come here to number 4. So you notice we've got all kinds of stuff going on here, okay? So first of all, let's do what we've already done before. Let's take our coefficients first, and let's see if there is a greatest common factor among these coefficients. Well, again, 25, 10. Let's take the smallest number and let's see what happens. I've got 1 and 10, and 2 and 5 are my factors of that number, right? There's very few factors in that number. And it may be the best to go ahead and take your smallest number and kind of think about it. Even though it's greatest common factor, take your smallest coefficient and really look at your factors of it first. So then I'm looking for the greatest factor, right? So does 10 go into 25 or 45? No. 5 is my next greatest common factor. And as a matter of fact, 5 will go into all these numbers. And so we know that 5 has to be the greatest common factor. So I'm going to go ahead and pull out a 5 right here. Okay. So I've got the coefficient dealt with. Now I have to ask myself, is there at least one x in every term? Well, as a matter of fact, there's 2 here, but there's only 1 here and only 1 here. So remember, I can only pull out factors that occur in every single term. Well, I can pull out at least 1x, right? I can pull out 1x, but that's going to leave me, and I'm going to go ahead and put a parenthesis. That's going to leave me 1x just kind of hanging out here, right? As a matter of fact, I'm going to just kind of write it over here. I'm going to put a slash and I'm going to put a 1. That way we know, hey, there's 1x that's left over somewhere, right? And then the other thing we're going to look at is, notice I have a y and a y and then a y squared. Again, I have a y squared here, but I don't have a y squared in every term. So the only one I have in common is one particular y right there. And again, that's going to kind of make this one that's going to be left over. So now let's think about this. Again, these y's canceled, these x's canceled. So all of that stuff is kind of gone. It's kind of already pulled out here in this greatest common factor that I pulled out. Well, what's going to be left inside my parenthesis? Well, 5 times what gives me negative 25? I need a negative 5 right there. And you notice again, what else do I need to make this match? Well, I had 1x that was left over, right? So it needs to be put right here with this particular term. But I've already kind of got rid of this, and I've got rid of the y. That was the only thing that was really left, okay? Now we've got 5xy times what equals 10xy. Well, we've already kind of dealt with the x and the y. The only thing left is the 10. So 5 times what gives you 10? It's a positive 2. So that's literally the only thing that's left in that particular equation, or that part. And then last but certainly not least, we have 5 times what gives you negative 45. Well, 5 times negative 9 would give me 45. I've already got an x, so negative 9 times x would take care of that x. But I'm left with 1y here extra that I couldn't get over here as a common factor. So that y would go right there, okay? So hopefully that's been beneficial to you. Again, these 4 problems you will see again on your practice. So you only have really 12 problems that you need to do. But these are going to really help us when it comes to moving on to factoring. So again, if you need any help, make sure that you reach out to either me or Miss Willer, and we would be glad to help you with this.